All available experts, please report to room A9.
Hello guys, Exeter here, and welcome to Angles. The point of this module is we are going to be figuring out which of these directions, encoded in different ways, is in the end, when if we paired up closest together points, the furthest away. It'll make sense when we get to this point. Unlike my matrices tutorial, I'm instead going to do the module first and then explain these, mainly because of how precise this module can be, and I'm not sure if I'll be able to get it right, so I don't want to go through the entire explanation just to get it wrong. So, let's just get started. So the first thing we have is over, which gives us relative directions. Relative direction is determined by step 1 of the solving process. Step 1 is draw a circle, make it the top bottom of this circle, go to left and right side. Do this from the observer's perspective, this being the observer's perspective. And we have the word over, so we've got the exact top of the circle. Next we have 3/9. This is just a number, so this is amount of turns. So we're going to be doing 3/9 of a turn or a third of a turn. So roughly a third of the way round, starting from the right, going counterclockwise. So, starting from the right here, a third of the way round.
All personnel, please return to your stations.
Round about here. And next is Aknam and Zam. So, this is where I'm probably going to use the arrows here to give me some better idea of where it is. So first let's get this to left. The functions of the buttons change depending on which screen you're on. And then we need to start from left and going counterclockwise. Not counterclockwise, regular clockwise. And just note that when it says these two numbers, that means 32 Aknam or 224 Zams. But let's, as you can see here, let's go down to the bottom here and we'll see needle movement table even, which gives us the accuracy we need when we submit our answer, but also how the buttons function when the screen is visible. So going down to Aknam and Zam, we need to go 22 Aknam, and we're going to be going this way round. So 4, 8, 12, 16, 20, 4, 8, 12, 16, 20, 21, 22, 1, 2, 3, 4. So roughly here. Next, we have a zodiac symbol, which is related to the date format. We're going to be finding our zodiac symbol. It's converted to a date, the one specifically where the constellation's boundary according to classic astrology. So we're looking for our one here, which I think is going to be Virgo here. So we're going to be going for August 23rd. August 23rd is going to be 22 days after this, which is 212 plus 22. What's that, right? Yeah. So 234. I'm going to put this 365, which is how much is one full turn, and starting from the top. So let's 1, 2, 3, 4. Wait, 1, 2, 3, 4. Let's go back to here. 1, 2, 3, 4. 1, 2, 1, 2, 3, 4, 5. There we go. Then go back to this one. You start at the top here. And going back down to here. The zodiac signs. Zodiac signs and date are actually exactly the same. But the holding condition is different for each of them. When I hold down the button, the needle moves to the first of the month for the zodiac one, but moves to the first zodiac period for the other one for the dates. So basically the opposite way round to what they show, basically. So on this one, we're currently pointing upwards, which means we're at January 1st. So just make sure which way we're rotating around. We're rotating that way. So we'll be pressing the down buttons again. There we go. You can see, for example, with this one, this is the direction we need to rotate. So we need to go, so we are currently on January. So we need to go February, March, April, May, June, July, August. And then we need to go 22 more from that. So that would be 7, so that'd be 8, plus 7 again is 15, plus 7 again is 22, and then 23. So roughly around here. Up next, we have Cartesian coordinate. This one is one of the harder ones to plot. You just have to sort of visualize it in your head. So sort of imagine the origin is here, and we're going to go. In this case, negative means we're going to go left by 4, and then 5 means we're going up by 5. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. You can see this is quite difficult. So we need to go like 1, 2, 3, 4. So we're on 1, 2, 3, 4 now. And 1, 2, 3, 4, 5. So sort of this sort of angle. So we're going to go sort of around there. That's the one I'm currently the least confident with. Up next, port bottom. This is the direction words again. Relative directions. So port bottom is left bottom. So bottom left. So pretty much directly next to this one. I feel like we should actually be labelling these what they are. So this one was over. Okay, this one was the 3/9 one. This was the Agnam Zam one. This one was this was one of the Virgo. This is the Virgo one, I think. This was the Cartesian coordinate. This one was port bottom. Okay, up next we have gradients. This is similar to like the degrees or radians you know about, but in this case the full rotation is 400. So first let's get this back to right, and we're going to be going this way round. And using the table here again, we need to go 110 gradients, so we can just press this one 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So pretty much roughly what you would expect it to be. How many do we have now? 1, 2, 3, 4, 5, 6, 7. Got 2 more, I think. Yeah. This one. Move this out of the way quickly. We have 5-3, which is a date. With date again. So with date again. So remember this, and going back to how dates work. This is referring to the 3rd of the 5th month. Dates in order are always listed month first, followed by the day. So we're looking at the 5th month, May 3rd, which is going to be 122. So we need to go 122. So let's get this back to, it starts at the top, right? It starts at the top, so let's try and get it back to the top. There we go. So 5-3, which was 122, going in the clockwise direction. It's basically, we need to go to May, so we're in January, so February, March, April, May, and then we need to go 2 more days on from that, so roughly about here. And last one, 7/8, so it's just another regular number, that's the amount of turns. So it's that one. We need to go 7/8 the way around, but again, remember that a turn starts from the right. So starting from here and going counterclockwise, 7/8 the way around. Well, going round to here we get 4, or halfway round. So it's going to be roughly in between these two. Which one it's closer to though? First of all, you should mark this one as the 5-3 one. And I'm going to make the prediction. This is probably where I might get it wrong here. let me use this again. Okay, thank God Christ it has the 8 turns. So we need to start from there, and then we want to do an 8th of a turn, but this way. So looking at this, it seems to be closer to this one. Okay, so now we go to step 3. After 9 total points, take the 2 that are near to each other and eliminate them, and then we keep on doing this until we have 1 left. So from what we figured out, the closest 2 I think are Pole Bottom and the Virgo sign. So we can eliminate these 2. Looking at the ones that we have left, seems like it's these 2. Then these 2. And then these 2. So my current theory is this is the one we're going for. The Gangnam one. So getting this back to where it needs to be, we need the left. And then going this way. You need to go 22, so that's 4, 8, 12, 16, 20, 21, 22, 1, 2, 3, 4. So hopefully, if we have got the right coordinate, then we get that module. Okay. So I luckily got some pretty decently easy ones there. The only really hard ones were Gradiums, I'd say, and Aknam and Zam. But now, despite being pretty much 18 minutes in at this point, it's time to do the fun part of just explaining everything else I didn't go over. Starting off with compass points. Compass points is interesting and it plays into hexacondates and peckers, as you can see here. See compass points. Because this 16-point compass rose might not be pointing in how you see it here. It might be pointing, use this, the first letter of the bond serial number, A to G, H to P, Q to V, or W to Z, where these words you can find up here to find out what they mean. Tells you where north is, here, and then you rotate everything round relative to that. And with compass points, I feel like a few people will be familiar with, pretty much everyone will be familiar with northwest, east and south. Northwest, northeast, southeast, southwest are the ones in between those. In between all of those is these ones in between. And then there's an extra one, which is quarterwines, which is denoted by the big letter, little b, another big letter or 2 big letters on either side. And it's basically it's found half between the first listed compass point and the next half wind in the direction of the second listed compass point. So So in this case, north by east would be the one just here. Hopefully you can actually see my cursor. It's the one between north and north-northeast, basically. We didn't have any arrows, but arrows are quite simple. Arrows consist of one line with a triangle on its head, and it's just basically whichever way they're pointing. Not to be confused with Sagittarius, which has the extra line here. Degrees, I feel like a lot of people are familiar with, but this is where it gets hard. They might include arc minutes and arc seconds, which are sort of divisions of degrees, I think. Yeah, it's like 360 degrees of a circle is separated into 60 arc minutes, which is separated into 60 arc seconds, so it can get extremely precise for this one, which is where the difficulty comes in. Radians do note that radians can be written in terms of tau instead of pi, but tau is just 2 times pi. So if you want to get in terms of pi, just double the number that's next to the tau, and then swap out the tau for a pi. We did Aknamsam, it's quite simple. It's just a different unit system. Slopes are interesting. You will either get a percentage sign on the left-hand side or the right-hand side. Right-hand side means it's rise over run. So basically, if it says like 0.5%, that would imply 1 over 2, and that would be a rise of 1, so going upwards by 1, and to the left, to the right even, by 2. If the percentage sign is on the left of the number, though, the positive horizontal distance is to the left instead, so be warned of that. And you can have negative numbers on that, if you were wondering, I think. Binary angular measurement. Binary angular measurement is shown as a binary number, where the 0b at the start can be ignored. It will just telling you it's a binary number. So you don't mistake it for a massive number instead. Convert binary decimal reading from left to right. Just convert this number into a regular number, and then follow the rules for working out just singular numbers as terms. Cartesian coordinates we had is just basically, if you visualize it on sort of a coordinate plane, where would it be sort of pointing to? Time, we didn't actually have time, but if you've seen a clock before, I'm shooting a lot of you probably have, so an analog clock, a 12-hour analog clock, when the minute hand goes round to the next hour, the hour hand has to move very, very slowly to get to the next hour as soon as the minute hand goes round. So the time you're given is where the hour hand would be at that time, if that makes sense. So if it was like 12:55, it would be after 12, but like pretty close to the 1 at that point. Dates we had in terms of both zodiac signs and regular dates. Just note that the date can be written as just like March 2nd or something like that, as the physical word March 2nd. And then flag semaphore we didn't have in the end. This one is also decently simple. Convert the letter in the flags to a flag semaphore sign using the flag semaphore table here. You assume the circle is facing you and they signal this letter towards you. Starting from the bottom going clockwise, if the letter is uppercase, the angle is there's the direction of the first flag. That'll be the left-hand flag here. And if it's lowercase, we are going for the right-hand flag. The table shows the signs from the observer's perspective. Anything extra we need to mention? We did this bit, and you can hold the button down to return to nearest whole increments, hence why in the table here they specified how that works with some of them. And then the solution accuracy, of course, if your solution is a relative direction, a compass point, an arrow, or in this case also binary number and flag semaphore, all don't have any deviation allowed. The other ones are a bit more exact, so they allow some deviation either side. So, for example, our the one of in Aknam and Zam, you got to get it within 0.5 of a Zam. Other than that, I think I don't really need to explain anything else. So, hopefully, you have at least a better idea of how at least some of angles works now. Just note that this table, the module notation is just what it will look like on the module. The name is what it's called. The starting point will tell you where the 0 point is for it. Of course, with some of them, there is no such 0 point, because it's not really rotating from a point, it's like relative to something else. D stands for direction, which basically tells you which way you rotate, and once again, some of them aren't rotations, so don't need that. And then the full rotation tells you how it's divided up around the circle. And then the asterisks here, some scales behave differently. I have actually noticed these are marked with an asterisk. If any of them don't have an asterisk, which is basically these ones because they work pretty much identically to the two ones above them, then that's when they have an explanation down here. And so these might not be entirely accurate to the standards that you would see where they would be used. Let me just mention hexacontents and pekkas here, because they're not mentioned here, but notice this dagger next to the east. This east is relative to the compass points that you've figured out, not actual east, so be wary of that. Okay, I think I've explained everything now, or anything I can explain. Sorry if I've missed anything out, but hopefully angles makes a bit more sense now. And I see you guys in the next tutorial. I see you later.